So again, I'm working on the assumption, no, na either nabasa niyo na yung lesson or napanood niyo yung video. But to summarize, the main lesson for this topic, itong arc length. So the idea is, marunong na tayo mag-measure ng areas under a curve, and considering na yung areas na yon ay bounded siya ng regions na hindi straight lines, yung taas niya yung curve mismo o yung baba at taas niya curves, nakita natin pwede natin gamitin yung calculus. Kasi nga, di ba, in calculus, we deal with very large and very small numbers. So pinaliit natin ng pinaliit yung areas para ma-add up sila na exactly. And we could also apply the same thing for measuring lengths of curves. Na kung hindi sila straight line, pero we could model them or we know how to plot them as a function, then we could use calculus to compute the distances of these lines. Or of these curves, sorry, hindi na pala lines, of these arc curves, arc lengths. And our formula from the discussion in the videos is, if you know yung function and you know the interval kung saan siya susukatin, the arc length is given by the definite integral from x equals a to x equals b of 1 plus dy over dx quantity squared dx. This is for kung ang integration natin ay along the x-axis, along the horizontal. Kung given sa atin na function ay y equals something. Pero hindi naman din masama na mabigyan tayo ng equation or relation, not necessarily a function, na x equals something, in which case, we could just, shift our view of the integral at mag-integrate tayo along y at magiging 1 plus dx over dy quantity squared if you are integrating along dy, meaning you're taking the derivative of the equation with respect to y. Okay? So itong ganitong notation, dy over dx, ito yung tinatawag nating Leibniz notation ng derivative. Yung f prime of x, yun yung kay Newton. Kasi tandaan niyo, 'di ba, may may away noon na sino ba naka-discover ng calculus, si Newton sa England, sa UK, or si Leibniz na French sa mainland Europe. So dahil magkaiba silang schools, yung Europeans, sila yung paulit-ulit na ginamit yung Leibniz notation, itong dy over dx. Sa UK, ginagamit nila yung f prime, f double prime, yung Newton's notation for the derivative. And eventually, it turned out, mas useful itong Leibniz notation, pero ginagamit pa rin natin yung kay Newton. But we only use that, kunyari, dito, no? Kasi we can't say derivative of we can't use yung f prime of x dun sa dx over dy kasi hindi naman function of x yung ano natin. Maybe you could use g prime of y or something, pero parang weird eh. So anyway, this will be our working formulas for the length. And dahil kailangan natin kunin yung derivative, requirement na yung function na kukunin natin yung arc length ay smooth. Meaning, continuous siya at differentiable. So, for my first example, we want to find the length of the curve x raised to 2/3 plus y raised to 2/3 equals a raised to 2/3. So, this is different from the examples that I gave in the video. Kasi dun sa video, meron tayong pupuntahan na definite na numero. But here, we're working towards a formula. Kasi a is, well, I should have mentioned, a is a positive constant. And it would help, no, if we take a look first kung ano itsura ng graph niya. Dami ko palang pinlat dito. Okay, so this is the graph of x raised to 2/3 plus y raised to 2/3 equals a raised to 2/3. Siyempre, pwede nating bagu-baguhin yung value nung a. So this is a equals 0, wala kang makita, siyempre. Then a equals 5. Notice na yung vertices ng figure, nandun sila sa negative 5, 5 sa x, negative 5 sa y, positive 5 sa y. And kung ano yung value ni A, siya yung location ng vertex o nung apat na vertices sa negative x, negative y, positive y. So what we want to do is essentially to find the perimeter of this figure. And the problem is, it's not smooth. Kasi if you take a look at, do you call this, x equals 0, meron tayo dong sharp na point. And we know from Math 5, hindi differentiable yung mga sharp points sa curve natin. Plus, one more thing, hindi siya function. It will fail the vertical line test. So, ano pwede natin gawin para hanapin yung perimeter niya? Cry! Grabe. Laman lang try before we cry. Kunin 1/4 lang. Exactly. Thank you. Thank you, Zero. Wow, kinorek ko niya. Edso. Okay, kunin natin 1/4 lang. Kasi we could just, take a portion of the curve, yung any one of the quadrants. And if we take just the part of the curve in any of the quadrants, then that would be a smooth function. So, kunin na natin sa first quadrant, no? Let's take a look at the first quadrant. Sorry, I should have, And in the first quadrant, we are taking the values from 0 papuntang A. So let's just take the positive values from 0 to A. So our formula or ang magiging approach natin is that the length is actually 4 multiplied by the arc length in Q1 or Q2 or Q3 or Q4. Pero Q1 na lang para positive lahat ng values na i-work natin. So, we need to find an expression for y. So, y is equal to a raised to 2/3 minus x raised to 2/3. So, sinubtract natin yung x raised to 2/3 from both sides. And then, i-raise natin siya sa 3/2. Okay? So, it's essentially, ano ba? You're cubing yung both sides. That's fine. Alam natin yon. But when you're taking the square root, tama ba? No, you're squaring. What did we do? 2/3, no? You're taking the square root of both sides. So you're raising it to the third power and you're taking the square root. So when you take the square root, usually meron kang plus minus. So we'll just take yung plus para makuha natin yung upper portion ng curve. Okay? But what we need to do, no, is to get dy over dx. So dapat may konti tayong remembrance ng chain rule for differentiation. And dy over dx, you take yung function sa loob and treat it as u, then take the derivative. So baba natin si 3/2. Unchange yung expression sa loob and multiplied by the derivative of the x term. So negative kasi negative x, then baba natin yung 2/3, then x raised to 2/3 minus 1, kaya negative 1/3. Okay. But what do we need? Hindi, sige, let's rewrite that muna in a nicer way. So 3/2 and 2/3, they will cancel each other out. X raised to negative 1/3, pwede nating ibaba sa denominator. Anong nakalimutan ko? 1/2. Yes. Correct. Thank you. Ayan, okay. Tama na, no? Yes, okay. So, let's multiply si 3/2 and 2/3. So, magiging 1 sila. Yung x raised to negative 1/3, that will go down to the denominator. So, our numerator will be a raised to 2/3 minus x raised to 2/3. Then, square root or raised to 1/2. Then, divided by, sama ko na yung negative. Negative x raised to 1/3. Tama ba? Yeah. So, yung kailangan natin actually sa formula ay yung square nitong derivative. So, dy over dx, quantity squared. So, mag-square lang yung numerator. Mawawala lang pala yung raised to 1/2. And the denominator becomes positive. Positive x raised to 2/3. Now notice, may term tayo sa numerator na negative x raised to 2/3. May term tayo, may yung denominator natin, x raised to 2/3. You could write this na a raised to 2/3 over x raised to 2/3 minus 1. Okay? And going back, no, that is why. Going back to our formula, so instead of length, I'll just use P for perimeter. Our perimeter, as we've established, is 4 times the arc length in the first quadrant. But the arc length in the first quadrant, using our formula, will be given by the definite integral from 0 to a of 1 minus the square of the derivative. But the square of the derivative plus 1 plus, not 1 minus. The square of the derivative is a raised to 2/3 over x raised to 2/3 minus 1. So, syempre, magka-cancel yung mga 1. And we'll have 4. So, unti-untiin natin. Square root from 0 to a. Square root ni a raised to 2/3 over x raised to 2/3 dx. Remember that a, very convenient, minus 1. Exactly. You will notice dito sa mga exercises, examples natin, no, halos yung mga examples ko cover natin, they're all very convenient. Kasi most of the time, for a lot of the functions, mahirap sila kuhanan ng integral pag nasa loob sila ng square root. So, yung mga examples natin, they're sort of convenient in the way na matatanggal natin yung square root. But in general, hindi. Mahirap. Mahirap kumuha ng arc length na may makukuha tayong nice antiderivative. 'Di ba? Kasi usually masa-stuck ka na meron kang weird expression sa loob ng square root, kaya pa mag-trig sub. Hindi rin lahat kaya i-trig sub. So yes, good observation. It is highly convenient na may minus 1. And a lot of our examples will be highly convenient na may mangyayari sa loob. So ilalabas natin, no, yung a raised to 2/3, magiging a raised to 1/3 na lang siya. So 4, we'll take out yung a raised to 2/3 sa square root, a raised to 1/3 na lang siya. Labas na rin natin siya sa integral. Integral from 0 to a of the square root of 1, sulat na natin, x raised to negative 2/3. Okay? Dx. And, tama ba? Yeah, tama. Okay. May notes ako eh, tapos na-confuse ako. Kasi pala sa notes ko, tinanggal ko na yung square root. So this is 4, a raised to 1/3 integral from 0 to a. You could drop the square root. Magiging x raised to negative 1/3 na lang. And this will give us, ano ba integral ni x raised to 1/3? So plus 1, magkakaroon tayo ng x raised to 2/3. Pangit ng x ko, sorry. X raised to negative 1/3 plus 1, 2/3 times reciprocal na 3/2, which will evaluate from 0 to a. So 4 times 3/2 is just 6. A raised to 1/3, a raised to 2/3 minus 0 raised to 2/3 will give us, surprisingly, 6a. So, ewan ko ha, this is one of those things, again, that I think are interesting, na if you take a look, ayan, if you take a look at this curve, and we're being asked to figure out yung perimeter niya, so wala siyang straight lines, we would hardly expect na yung magiging result natin, wala siyang square root of something, wala siyang pi, kahit may curves. It's nice and neat 6 times a, where a is the distance from the center of the, how do we refer to this? Concave square? Of the concave square? Yung distance from the center to the vertex, one of the vertices, is a, 6 times nun yung magiging perimeter niya. And, that's sort of maybe not obvious looking at the curve. Pero yun, I like it. I like the idea na ang neat nung sagot natin even if hindi natin siya masukat directly. So yun, I hope may ganun ding impact na, oh, it's a nice solution. We don't get that very often in calculus na ang neat-neat nung sagot natin. Anyway, let's move to the next example. So ito naman, again, it's slightly different now. We're not looking for an exact measurement of the length. We are given a function y equals 1/4 times the exponential of x plus e raised to negative x. Yung arc length daw nito for any interval will have the same value as the area under the curve. So I think I plotted that here. So let me just show you. So ito yung equation, no? Ito yung plot ng equation. It's not very interesting. Mukha siyang quadratic. And ang sinasabi nung problem natin is that if we take the arc length from any interval, let's just put a random interval. Kunyari ito, yan. Yun daw measurement, yung numerical value nung arc length na makukuha natin in that interval is equal to the numerical value of the area under a curve. Pero syempre, we're measuring different units, no? Kaya ang hirap i-visualize. Parang, malay ko ba, hindi ko naman ma-prove visually. Kasi yung isa, one dimension. Yung isa, two dimensions yung measurement. But the numerical value daw is the same. So, it's kind of hard to see from the figure. So, I guess, ang gusto ko lang ipanote sa atin before we solve for this is that the entire curve, the curve is entirely above the x-axis, positive siya for all values of x. Okay. So, what's the arc length? The arc length from our formula is the integral, well, from any interval daw eh. So, let's just use a and b of the square root of 1 plus, this is f of x. So, pwede natin gamitin yung notation Newton. F of x quantity squared, f prime of x pala, quantity squared, dx. So, i-solve muna natin siguro yung derivative. The derivative of our function. By the way, no, alam natin yung exponential, siya yung may particular na property na pag kinuha mo yung derivative niya, it doesn't change. Pag kinuha mo yung integral niya, aside from the plus c, it doesn't change. So, yung mga ganitong weird stuff na, oh, yung arc length, tsaka yung area under the curve, malamang lalabas pa rin si exponential. Kasi medyo, siya eh, invariant siya sa kung ano-anong, sa mga calculus na operations eh. Invariant, it doesn't change. So its derivative will be 1/4 e raised to x minus e raised to negative x, di ba? So, when we find yung square ni derivative niya, hindi ko i-expand. I mean, basta, sulat ko siya ganito. 1/4 e raised to x squared. Hindi ko i-distribute yung squared. Minus 1/4 e to the x times negative e to the negative x. So, magiging negative 1/4 times 2. So, negative 1/2 plus e raised to negative x quantity squared. So, ito yung ating square nung derivative. Papasok natin siya dun sa ating formula. So, again, yes, magkakaroon tayo ng convenient na one or convenient na something. So, I'm copying the problem, the result dito. No? Okay? And the thing to notice is that meron tayong convenient na 1 at convenient na negative 1/2. So, of course, that adds up to 1/2. So, makuha na lang natin sa loob ay ganito. Pero, if we compare yung nasa loob ng integrand natin, no, with yung nakuha nating result dito sa square root, pinalitan mo lang yung middle term eh. ng ano, ng from negative 1/2 to positive 1/2, right? So, it's essentially still a perfect square trinomial na imbis na negative yung ano, yung second term sa binomial, it will just be positive. So, it's equal to the definite integral from a to b of 1/4 e to the x plus e to the negative x quantity squared dx. Okay, di ba? And you have yung square and you have yung square root. They cancel each other out, pero technically magiging absolute value siya, no? But if you remember from the graph kanina, all the y values of the function are above the x-axis. So you don't need the absolute value symbol. Positive palagi yung square root of, positive palagi yung nasa loob ng parenthesis, yung nasa loob ng square. So we'll just write this as integral from a to b of 1/4 e to the x plus e to the negative x dx. So ito yung arc length, no? Pero ano ba yan? Yan din yan exactly yung original function. And if you take the integral of the original function, and then you get the area under the curve. So since yung ating formula for arc length just brought us back, no, sa integral of the original function, and then the numerical values of the arc length are equal to the numerical values of the area under the curve. So this is also equal to area under the curve. And I guess, isip ko tuloy, may nakalimutan ba akong step? Or pwede ko nang i-declare na tapos na yung proof natin? Dahil nakarating na tayo sa definite integral of the function. Dapat pwede na yan. Questions? One last example. So notice, there's not, wala akong magawang particularly complicated na question sa arc length. Hindi tayo magtatanong ng arc length na yung integral sobrang hirap. Pwedeng mangyari yun. Madaming ganun. Pero hindi yun yung point eh. Ang point natin, ma-set up natin yung formula. For now, yun yung point natin ngayon. Kasi kumbaga, ginawa na natin yung second quarter yung difficult integrals eh. So right now, what we're doing is applying yung applying yung idea ng definite integrals. So I don't know if that makes third quarter easier or harder. Pero I think we're past the point na we're doing difficult integrals. Uulitin niyo yun sa calculus series niyo sa university, I think. But at least nadaanan niyo na siya once. I think it's very helpful. So yun, we're just setting up here. Set up the definite integral to find the perimeter of this region. So let's take a look at the region. Mas madali pag nakikita na natin. So we have three curves. Yung isa ay y equals x cubed plus 1/2. Yun yung kulay red. Yung isa ay x equals negative of the quantity y minus 1/2 squared. So that is not a function. That is a parabola that opens left. It fails the vertical line test. And yung third is just a constant line. Y equals 3/2. So we're looking for the area of this region. Hindi ko na na-shadean. Hindi ko alam gawin sa Desmos. Sorry. Alam ko pag dalawa. Pero pag tatlo, hindi ako sure. So yeah, we're looking for the area of this region. So let me try to sketch. So I think gumamit ako ng green sa taas. Tapos may parabola that opens left na blue. Tapos may kulay red na pangit. May kulay red na na cubic. So the cubic has equation y equals x cubed plus 1/2. Yung kulay blue, sorry, has equation x. Ano ba tong prep pa ako, mali naman. Should be x. Okay. Yung kulay blue ay x equals negative y minus 1/2 squared. And yung green is just y equals 3/2. Okay, kailangan may nag-message. So we'll cut it into three parts. Let's call this the first arc length. What did I designate as the second? It's called yung red yung second arc length, yung blue yung third. So clearly, yung ating magiging perimeter is just L1 plus L2 plus L3. Yun lang naman yung bounds ng region natin eh. So pinakamadali, syempre si L1. Kano kahaba si L1? Tingnan natin yung picture. It's just the length ng green. And yung green na yung green na line, nababound, ano ba yung tamang term? It bounds the region from x equals -1 papuntang x equals 1. So may length siya na 2. Okay? So L1 equals 2. That's it. The second length, ito natin i-compute, is a function of x. So pag nag-set up tayo ng integral, it will be dx. Ano yung ating range? Ano yung ating limits of integration? Take a look at the red na portion. It is from 0 to 1. Kasi ang tingin natin along x eh. X equals 0 to x equals 1. So from 0 to 1 of 1 plus the derivative of x cubed plus 1/2 quantity squared. So that's just 3x squared squared. And yeah, that's it. Na-set up natin siya. So madali lang siya, pero if you will recall, hindi siya ganun kadaling i-integrate. Kasi meron tayong 1 plus, ano ba to? 9x to the fourth sa, mali. Sa loob ng ating radical. Even if we use u substitution, u is equal to 9x to the fourth plus 1, edi yung du mo, x cube, wala kang huhugutan ng x cube. So yeah, hindi natin to gustong i-actually solve by definite integrals. But you know what this looks like essentially. And we could plug this in sa Desmos or something. So okay na yan. The third region is not a function. So kailangan natin siyang kunin as an integral along the y-axis. So again, let's figure out yung ating bounds. Oops. Figure out yung bounds. Kung tayo sa blue naman titingin, yung y values, kasi along y yung ating integral, it goes from, di pala makita, kung maliit pa rin yung number kahit mag-zoom in ako. No? So it goes from 0.5 to 1.5. So 1/2 papuntang 3/2. So our definite integral will go from 1/2 to 3/2. Note na y values to, no? So in our formula, we are integrating along y. So dy yung ating mga differential na regions. So ano ba to? Formula 1 plus, then we'll have to get dx over dy. Dx, sorry, dx over dy, ano ba yung function natin? So x is equal to negative y minus 1/2 quantity squared. So dx over dy is negative 2y minus 1/2. Yeah, that's it. Yun na yun. So square lang natin siya. That will be negative 2y minus 1/2 squared. So we'll have f integral from 1/2 to 3/2 of the square root of 1 plus 4y minus 1/2 quantity squared. And we'll stop here kasi we're just setting this up. We're not intending to evaluate the definite integral talaga. So the perimeter is L1 plus L2 plus L3. I guess yung gusto ko ipakita sa example na to ay pwede natin siyang i-apply yung formula kahit hindi function if we take the integral along y. It's equal to 2 plus the definite integral from 0 to 1. 1 plus 9x to the fourth. Ito yung nakuha natin kanina for L2. And L3, which is yung along y na integral, 1/3 So 3 halves, 1 plus 4y minus 1 half dy. And this will be our final answer for this problem. So yun, it's really just an application of the formula, and siguro na hindi natin nakalimutan paano magkuha ng derivative ng mga functions natin. So, konting chain rule, yun lang naman, at mga common derivatives. So, any questions? That's my last that's my last example. So, kung wala naman kayong questions, pwede tayong matapos ng mas maaga. So, yun, confirm ko lang na walang tanong. Wala naman. Greet ko lang yung hindi ko na greet ng good morning kanina. Colleen, greet ko yan sa Colleen. Anyway, kung hindi, good morning. Marel, good morning. Si Antonio ba na-greet ko? Good morning. Good morning, BJ. Good morning, Daryl. Si Gerard, di ko yata na-greet. Good morning.
Morning,
Ito,
sir.
na-greet ko to. Ha, yun lang. Okay, konti natin. Okay, so thanks guys. And yung mga nakita ko noong Tuesday, natuwa naman ako. So I'm really looking forward na kahit paano makita tayo. Kung hindi man sa classroom, no worries kung late. Hindi man sa classroom, at least siguro naman kaya natin mag-graduation ng face-to-face, no? Medyo malayo na yun. So, please, kung makita tayo sa campus, please say hi. I really be happy to get to know you. Magkaroon man lang ako ng face sa name, di ba? At ma-realize ko, matangkad pala kayo sa akin. Ganun. Wala, natutuwa naman ako doon. So, sana, tuwa din kayo makita yung mga teachers. So, that's it. Goodbye and thank you guys. I'll stop recording na pala. And I'll see you next week. Enjoy your long weekend and stay safe.